All right, everybody, please take your seats. This is the second edition of the TLS Working Group meeting. We already have note taker and we have Jabber Scribe, and so we're ready to go. The one thing I would, the pen. Please remember the note well from this morning. There's a test. All right. Wrong thing. Okay, session 2 agenda. So for this session, do we have? Okay, so we will have somebody potentially be adding just a short, brief discussion on ticket request. Not really a discussion, but an update when David gets here. And we're going to switch the order of deprecating MD5 and the well-known URIs for ES&I. And I think if we have time afterwards, we'll start a charter discussion. If we have time. Does anybody have any other agenda modifications they'd like to make? Excellent. Who's going to present on?
So hello. So I think 10 minutes is more than enough. So it's since the last time we've made only one change to the draft.
Sorry.
Space. Okay. There was just one concern. It was regarding this change where concerning signature algorithm extension, where we just added a few, one clarification to it. And if everybody is good with that, I think we can proceed. That's fine. So it's all on the GitHub. Okay, so we basically made the change, including instead of saying a client does not send a signature algorithm extension, then the server must abort the handshake and send a handshake failure alert. We change that to if a client does not send a signature algorithm extension, then the server must abort the handshake and send a handshake failure alert, except when digital signatures are not used. And we've included an example, for example, when using PSK ciphers. I believe that it addresses the concern that was made during the previous IETF.
So is that the only outstanding issue on the draft?
Yes, that was the only, as far as we remember correctly, yes.
Okay, great.
Alessandro Ghedini, Cloudflare. Yeah, I think this was the only comment that we got the last time, and the other people were saying, well, maybe we can't disable MD5 and SHA-1 now, but we should proceed with the draft.
Yeah, because my very next question is like, who's read? I would like to move this to working group last call, if you haven't noticed. So I want a show of hands of people who have read this draft. I mean, 10. So unless there's any raging objections to what's in the draft now, we would like to proceed with working group last call. All right.
So thank you very much.
I don't know. I mean, it's not behaving the way I expect. Do it now. I don't know.
So so this is just something added extra for ESNI that came up when we were implementing it and needed to publish keys. So basically, I have some Apache and Nginx Lite that are ESNI enabled web servers. I update the keys regularly. Need to publish them in the DNS. I don't have DDNS, but I do have a machine that kind of creates its own files and then has a hidden master and all that kind of stuff. So I need a way to pull the ESNI keys from the web server machine into the thing that produces its own files, and a well-known URI makes that easy. So I think it'll be worth defining somewhere. Looks like that. So you have in this case, the public name is the site I go to. Doesn't have to be that, it could be something else. And then below the well-known URI, there's the name of the hidden site. And what I did was just dump a JSON array of the keys that need to be put into the zone file. And so could be adopted, could be added as an appendix, could send it to the ISE, whatever. But I think it's kind of useful, particularly for kind of, not necessarily for the main ESNI use cases of big CDNs, but for people who have small numbers of websites, maybe multiple virtual hosts. So I don't really mind what way we handle it, but I think it would be good to define it somewhere, and feedback appreciated.
Oh, great. The line's forming because I was going to ask who's read it. So can we do that at the same time? Can I have a show of hands?
There's not much to read.
I know, it's really short. Okay, great. All right. We'll let the line form now. Remember, we have an hour. We want to actually talk about the ESNI solution. So let's make sure we keep this brief.
Ben Schwartz. I think it's great to make ESNI easier to deploy. I imagine that you have to make a change somewhere in your hidden master to tell it to go fetch this stuff, right? You at least need to flip one bit somewhere, configuration flag, to say go check, see if this exists.
What I've done for now is just a cron job that does it hourly, and then what it does is it just pulls this URL, check if it's different, check if it works, and then publish.
Mostly I'm trying to figure out if you need the .well known or whether you could basically tell your hidden master, like, here's the URL to fetch the ESNI keys.
I guess it doesn't necessarily need to be that well known, but yeah. I'm not a HTTP purist. I'm not a purist of any kind, really.
Daniel Kahn Gilmore. I like this. We should be working on it. You're describing this as something that your DNS authoritative server would check. And I'm wondering whether you've contemplated this being something that the client actually might check as well, as a way of bootstrapping to ESNI. I mean, I feel like we should acknowledge that that is a likely scenario. Not everyone's going to have access to their DNS server that's going to be able to run a cron job the way you're talking about.
Yep.
I also think that this should specify the some sort of MIME tag. Can we just register a MIME tag for it? Just so that we know what it is.
People want it, sure.
Tommy Pauly, Apple. Yeah, I think this is an interesting thing to do. I think it would be good to explore whether or not we really need the well-known for it, or we can do it another way. So something to look into. So when we're asking the server for the keys for a given name, how do I know which names I can ask?
In my setup, I just know, so it's just configured onto the DNS infrastructure.
Okay, it may be good to at least have some considerations around that, because potentially if this is something that the server isn't able to give me the keys for, I've now told the server I'm accessing this name. Like if I have a mismatch and I'm sending this well-known to some random rogue server, not a rogue server, but someone who's not really authoritative for it, I've just sent it a whole bunch of names.
Fair point.
Yeah. Thank
you. David Skenazy, Google Chrome. I think this is interesting. Yeah, let's bring it. I don't know, here versus HTTP, it's always tricky. I like well-known because this is a server-wide policy thing, and so preventing, like if it's a blog, a random page from changing policy is generally a good thing, but let's keep this here. I like it.
Eric Rescola. So what are the semantics of this in multi-CDN use cases?
It beats the crap out of me.
Right. So that seems perhaps something that should be resolved before we take this too far.
Sure. Yeah, I mean, what I did, I did this for smaller things. My assumption is that, my assumption is CDNs will do something internally that's God knows what it is, but definitely agree that if there's an issue, then we should
Right. So I guess like, just in terms of what we should do, perhaps have a couple spins at the crank before we do much of anything.
Oh yeah, sure. I mean, I'm just,
Interesting idea, but I think like I'd like to be sure. I guess as we're discussing later, ES&I is a history of like us doing things and discovering they stink. Of which I'm a prime offender. But so perhaps that's what we should figure out here too.
yeah, and you know, I'm really happy to change my code to do whatever people want to do. So it's not that big a deal. Phil?
PHP, yeah. And kind of, I think that this might turn out to be problematic because at the level that you're doing the ES&I authentication, you're really talking about keys that have more to do with the host connection rather than the service. And I think that the conflict between the two might I think it might be problematic.
Okay, if there's cases where it's problematic, it'd be good to know that, yeah.
Daniel Kahn-Gilmore again. I think one of the things that maybe this draft ought to explicitly state is whether this is expected to be an exclusive list or an additive list. That is, if it doesn't exist, what does it mean that it doesn't exist? If it has one element in it, what does that mean if another element is discovered in some other way? Right, that's, I think, the trickiest part for thinking through what this means, because now there's two different ways to get ES&I keys, and how do you juggle those things?
Okay. So thanks for the feedback. Yeah, what do you want to do? I mean, if I got that feedback in mail, I'd happily incorporate it in another rev of the personal draft, and then you can think about it.
Why don't we do that? Why don't you go ahead and revise it, and then we'll, not wait till the next meeting, but, after you've revved it, we'll go through it and do it.
So please, if you said something that might send me mail or send mail to the list saying what you said, because I won't remember.
Well, we got a minute taker too, so, our excellent minute taker, Joe.
Nobody ever reads the minutes.
Yeah, well,
Thank you.
yeah. David, we actually agenda bashed, so you're going to be next. He doesn't have slides. We're just going to talk.
Sorry, this was just a quick last minute non-presentation, I guess, no slides. So I'm David Skenazy from Google Chrome. I'm just going to really quickly talk about the draft TLS ticket request. So 32nd point of the draft is today the server decides how many tickets it sends to the client. Some clients need less, some clients need more. So this is a absolutely trivial extension where the client says, I want N tickets. We talked about this at previous sessions. It is now a working group last call. We had a good positive conversation over the last couple of days on that working group last call. I chatted personally with Daniel. Are you in the room? I don't see him, with Daniel Migo about this. And this is my kind of personal opinion of what we've been seeing is people like this, there was some support, and but there were a few questions and it got a little bit confusing, and we tried to clarify that. So it sounds like folks, so the number of tickets you request is non-normative, as in it's a should, like you don't, the server doesn't have a must. Daniel was interested in having that because he had an IoT use case where if he says I only want 2 tickets, if you send him more, it actually uses up his resources, and that's kind of bad. But server operators chimed in saying like a must is a bad idea because that's really hard to implement for a bunch of reasons. So the sense we got is that the folks that participated in this conversation wanted this to be published even with a should, and they were okay with it. So we're just, I guess, asking if anyone disagrees with that statement, please come here. Can we have that conversation here? Otherwise, like, chairs, let us know how you're feeling about the working group last call. Is it going? Where do we go from here?
So I think what we've done is we've uncovered there was one issue in this draft. So what we can do is a second working group last call just on this particular issue with the actual text changes, if any, and just knock it out. Does that sound like it's reasonable? Because I'm not seeing anybody run to the microphone to say we think it ought to be a must, or we think if somebody wants, more people want to pile on to say it's a should, that'd be great and helpful too.
And one thing I forgot to say is after that conversation, I have a PR out right now which kind of rephrases it. It's purely blanking on the word. Not any normative changes. There's purely
So it's just purely
editorial. Thank you.
Okay, great.
Tommy.
Tommy Pauly as a co-author in this. So I want to also emphasize, I think pointing this out and the confusion it generated was very good for the document, and looking over the text that you reworked, and thank you for doing that. I read what I was kind of thinking all along there, so I think it's what was intended to be said. So I think you did send that to the whole list.
Yeah, and we've had a good conversation today.
Right.
To answer your question, this is already the second working group last call. Would this be a third
I don't
one?
know if it needs another call
Yeah.
entirely. If we can just agree on the list that this was the right change.
Okay. Because Martin Thompson did raise the point at the first one that he supports this, but every time we have a working group last call, he'll come up with something else to say. So maybe at some point we need to stop. Up to you, but like just maybe let it run for another few days to make sure everyone has had the time, because we're all not necessarily checking email today, but maybe not an entire working group last call. That might be a bit much.
So you've posted the PR already to the mailing list.
Yes.
All right.
And
So I'll pile on top of that to say, like, look, this is the thing that we talked about at the working group. This is what we're going to do. If you're going to scream now. Otherwise,
yeah.
All right.
And like people were like, oh, well, I would have kind of preferred it that way, but I'm okay with this, and I prefer this moving forward.
I mean,
So
right. So this is rough consensus, right? This is like, can you live with this? Not, do I want to fall on a sword? So
yeah, and an important thing, like a lot of the proposed changes were editorial, and we're going to have an IETF last call where we can make even more editorial changes. So this isn't the last call.
Fair enough. All right. Time for the main show, Ecker.
Thanks for having me.
Thank you. I like this. It's nice yellow slides, high contrast, very important. Well, they're orange.
It's like color correction. These things need some work. It was safety orange when I put it up. Okay. This really should have been called encrypted SNI this time for sure. Backstory here is we keep taking stabs at this, but having some problems in terms of getting the security model right. I feel like, we're at the stage where we were with, like it took a long time to figure out how to like get TLS right. And apparently like we're trying to do this in a compressed time, and this is actually more complicated. So there's been, so I'm reporting now on, I think, the result of a pile of work by a pile of people. In particular, Chris Wood and Karthik Bhargavan did an enormous amount of analysis of like why we'd been having problems in the past. And then the design team, or I'm not sure we have a design team, but a team of people got together and like banged out about 97 different options, and then we tried to figure out which one to do. There was some talk about like actually trying to walk you through the reasoning, and I vetoed that because it turned out it's like we spent about 20 minutes on this morning, and like spent most of that being like, wait, what are we talking about? So I'm not going to do that. I'm going to walk you through what we propose we do as the outcome of those discussions, as opposed to the reasoning for it. We have documentation as linked in here for like the analysis that we did that kind of walks through the options, and we'll keep that updated. So like there'll be some record you can read about why we think it's the right thing, but it's just too hard to track in a meeting like this. Next slide. See, I'm not used to having this. So we did 04, had some problems. I'll walk through a couple of them, but basically there was a number of ways to extract the name of the server you're talking to, which obviously is kind of obvious the point, because we're trying not to have that happen. They were all like active attacks, some better, some worse. They do not, in fact, threaten TLS itself, but like since the point is to suppress the knowledge of the SNI, like obviously that's not good. Here's the first one. With a nice little MCS diagram. This is basically a ticket oracle. So the idea is that the attacker goes and the attacker connects to the server that he thinks you might be connecting to, and acquires a ticket of his own. So the ticket is bound to example.com, right? Or in this case, X. And then what the attacker does is he captures the client hello, and he slaps on his own PSK and PSK binder with ticket for X. And then he looks to see and then he looks at the server's response and sees that the server like accepts the ticket. And if the server accepts the ticket, then it's probably the right SNI. And the server doesn't, if the ticket is probably the wrong SNI. It's not like perfect because of multi-CNs and like maybe the tickets have a long lifetime, but it's a leak, especially if he's like does it really quickly, right? So so this is one kind of thing. This is like a reaction attack on the server. So that's not great. The second attack is this HRR attack. So basically, the idea is there's nothing connecting like HRR1 and HRR2. So the client sends the first client hello and does the SNI, and then the server like responds to the HRR because like this client's got the wrong key for some reason. This is like totally the attacker's not doing anything here. This is just like bad luck on the client and the server. So the client like generates client hello 2 and regenerates the whole thing with an ESNI block, and the server like strips out the ESNI block, and basically strips out just everything, right? And so now this is sort of an attack on like a kind of screwy server implementation, but the idea is that the server has like remembered the SNI from the first connection and it's actually using that. And if that happens, which you shouldn't do, but if it does, then basically the server will like will like ignore like the ESNI block that the attacker strapped on and like bolted on or whatever, and go ahead and complete the connection with the SNI and the certificate that was corresponding from like, is this also a laser pointer? Oh, well, that sucks. No, it's not. With the ESNI, the corresponding certificate from the initial client hello, and since the G to the X came from the attacker, like he sends the certificate to the attacker. So how convenient for the attacker. Again, like we could tell like a server's not to do this, but like there's some concern servers met anyway. So it seems like we want to have a defense that like makes it hard to do on the server. So like when you sort of try to, and this, as I mentioned, Chris and Karthik kind of sat down for 2 days in Paris and like worked out like an attempt to analyze like what the source of these problems is. Like what are the things, what are the principles we're violating that's causing us to have this problem? So the conclusion was basically it's like a lack of things being bound together, which has like been a persistent problem with like TLS across the years. So basically the ESNI and the client hello contents, because we're only binding the key share, we weren't like binding anything else. Between the client hello and client hello 1 and client hello 2, and between the ESNI and the remaining secret and the handshake secrets itself. That is the keys used to encrypt the handshake. So basically the fix for this is like aggressively bind all these things. So the first thing we want to do is like bind the entire client hello. And so one thing we could have done is we could just extended like the AAD that we're already using to bind the key share. But A, that's like hard to implement. And B, it's like, well, that's actually quite inconvenient because well, that's less good than you'd like, because we'd actually like to cover as much of the client hello as possible, not just encrypt the SNI. It's just that we don't encrypt the SNI because we thought it was like easier to work with, not because we didn't want to like hide the LPN. So basically the idea here is to tunnel the entire client hello under encryption. And I'll explain how to do it in a second. Second, to tie the client hello 1 and client hello 2 so that basically you know that client hello 1 and client 2 are connected. And finally, to make the handshake secrets depend somehow on the ESNI block. You'll notice like these last two, there's a little bit of hand waving going on because we're trying to figure out exactly how to do them still. So here is like, I've added some disclaimers here, as you can see. I was trying to figure out how to add some more. So basically the idea is that we have a new extension called the client encrypted client hello extension. You're gonna love that one. And this looks pretty much like the old ESNI extension. It's got a cipher suite that tells you like what you're using to encrypt under. It's got the Diffie-Hellman key share that's like your half of the HP key system that's like telling the server how to drive the key. It's got the record digest, which tells you which ESNI record you're using. This is all old. It has this new thing called a CH1 binder. You'll listen to TBD. I was hand waving it, but basically what it is what connects CH1 to CH2. So in the case of CH1, it's probably empty. In the case of CH2, it's got something that's derived from CH1. I was saying hash. Karthik had some worries about that. So maybe it's like a derived hash, but something. And then finally, there's what used to be called like ESNI, and now it's called encrypted client hello, which is like an entire client, which is the entire client hello that you started with. So the idiom here is a client generates like a client hello, like encrypts the entire thing, generates a new client hello and stuffs the encrypted client hello in the original client hello. So now the relationship between these is a little fuzzy. I think in my intention was to generate them like entirely independently, essentially. But in particular, one opportunity you'd have would be to have the exterior client hello be dumber and less interesting than the interior client hello. There's some tension here because on the one hand, that makes it easier, it makes it harder to grease the existence of SNI, but on the other hand, it makes it harder to fingerprint the exterior client hello. So some tension between those two. So one immediate question that happens is like, what is the transcript here? Because now, previously we had like a transcript, which we had like one transcript. We had the like thing with the encrypted SNI in it. And now you have two. You have, if the ESNI is accepted, namely if you know the ESNI key, then it's the client hello inner. If you are in fallback mode, which is to say you've forgotten the SNI key and you're gonna basically complete the handshake with the public name, and then deliver like a new SNI keys record, but I can't remember what section it is, but with Adam Langley's fallback hack, then it's client hello outer, which by the way includes encrypted client hello inner. So how does the client know what happened? We went back and forth from this. One thing you could do is you could actually have like an extension in the server hello, but we concluded child decryption was fine and would like be like make it harder for attackers to figure out what's going on. That may be something we imagine reversing later. So like, why does this work? So obviously the entire client hello is protected, so that prevents you from changing any piece. So you can't like replace GDDX with your own GDDX. You can't like add a PSK binder, which was, remember, was part of the session ticket attack. So it has that. Client hello 2 contains a hash of client hello 1, so that prevents mix and match attacks between them. There was several attacks here. One by Nick Sullivan, which I didn't show. And finally, the handshake secrets depend on the ESNI block. There are actually two ways to think about to have this happen. One is that we have the ESNI nonce that we already had, or alternately, as David Benjamin suggested, you have the client hello random be different between external and internal. And so since that affects the handshake keys, that means that anyone who doesn't see the ESNI block, the client hello inner, therefore can't derive the key material. The second option, which is to explicitly take some value off the ESNI keys block and shove it into the key schedule explicitly, rather than sort of implicitly via the transcript. So one option is basically, right now we're not using HP key, so you have like the ZZ from like the Diffie-Hellman exchange around ESNI, and you can just HKDF some other thing off it and shove it in the key schedule, like at the 0 or with the extended key schedule stuff Jonathan was talking about. So these are two options. We haven't quite decided between them. I'll talk for a minute later about why you might want one or the other. So like objection like one is like, wait. This is like really big because like you have like client hello inner and you have client hello outer and the same, and so like now it's like twice the size. Like, so this is not like a crisis like most of the time, at least right now, because these things are typically pretty small. And like in Quick, in fact, you've got to like basically pad the whole thing out to 1200 anyway. It's like, which is like the thing is mostly padding. But if we're going to do post-quantum key exchange, we're going to be kind of like sad people because like these things are really big, and now like having to be twice as big is bad. We came up with this hack, which is basically that you hoist the extensions like out of inner into outer, or out of outer into inner, however you want to think about it. The bottom line is the extension, like when the client generates client hello inner, anything he's duplicating, which probably would be key shares in this case, he basically generates the whole client hello inner, including the PSK binders if there are any. And then as part of the process of encrypting, right before encrypting, he like hoists them out and replaces them with like a stand-in that basically says, go look in the outer for this thing. Then the client-facing server, after decrypting the ESNI block, restores them so you have a complete client hello as it's supposed to be. And obviously they have to be authenticated because otherwise you have the problem of like mix and match attacks again. So there's got to be something that authenticates them. In the PR that I have, basically I had just like some extension that says like, this extension was coming from the outside and here's the hash. David Benjamin points out that means that like you can only use this trick for like things which are inherently super large, as opposed to things which are small. There's some tension about how much we want to encourage people to do this. There's some discussion on exactly how to spell this, but the bottom line is it's got to be like, be able to pull it back out and back in again, and it has to be authenticated. But the bottom line is at the end of this process, you end up with like an ordinary valid client hello, including if there's a PSK binder, that PSK binder is valid because you put like whatever you took out back in again. So whoever told you couldn't compress encrypted stuff? So I guess there were other way around. Okay, so one of the big open issues here is this handshake keys thing. As I said, the handshake keys must depend or be depend on the ESNI block. Otherwise, it's HR Oracle problem. It's clearly the case at some like trivial level that if we have like the nonce or we require a different client random, then it's part of the transcript and that it becomes part of the handshake keys. So this seems to have the nice property that maybe it allows like an unmodified backend server. There's the big maybe there. There's like a number of reasons why you might think an unmodified backend server might not work. As one example, as Nick Sullivan pointed out to me lately, it may not be padding like the certificate, in which case like you might be kind of sad about that. We have to decide how much we value that. The sort of annoying part about this is it requires some more assumptions about the transcript secrecy and the nature of HKDF. So we don't ordinarily assume that the client hello is secret at all. And so if you had some problem where like TLS leaked the client hello in some way, then this whole thing falls apart. And so like as an example that Karthik pointed out, imagine that you built your stateless HRR mechanism by like taking the entire client hello and like stuffing it in like an unencrypted but like authenticated block in the cookie, right? Now you'd like obviously have a kind of a problem. So like that maybe seemed like far-fetched, but there you go. So option 2 is to throw away the nonce. So you don't need the nonce anymore at this point, I don't think. And then somehow take the ESNI shared key and generate a new key off it and shove that into the key schedule explicitly. This obviously requires modifying the backend server, and it requires not just modifying the backend server, but having a way for the front end server, if they're split, to like tell the backend server what the key was, so we can shove it into the key schedule. So that's like sort of annoying, requires some coordination. On the other hand, it seems to rely on substantially simpler assumptions because like you don't have to worry about the transcript secrecy. One thing you might worry about, however, is what happens if the backend server, front end server lies about what goes into the key schedule. I don't think that's a problem, but Jonathan's talk earlier this morning made me worry about that a little bit. So something we have to think about. So our proposed resolution here is to start by publishing draft 06 just to get like most of the underbrush out of the way. Use option 1 because it's like more straightforward to reason about, and then do modeling on both and follow up in the list. I think from the perspective of the people, my perspective, and I think other people looking to deploy this quickly, a lot of the uncertainty here is about like getting the DNS pieces working and getting some experience getting anything working at all. And if it turns out that we're like rolling it out and like there's something subtle that creates like a reactive attack to like extract the SNI, like that's obviously not good. But if all we're doing really is trying to get some deployment experience, then it wouldn't be a disaster as long as it doesn't implicate TLS otherwise. If someone else thinks that that analysis is wrong, I'm certainly inclined to hear it, but I think that like lets us make some progress. And we expect that it'd be the same software in either case, relatively similar software in either case. So again, like I say, we're right at deployment experience in terms of getting ESNI out in the field. And like because right now the SNI is leaking all the time. If it turns out that like ESNI does not in fact predict the SNI that we're hoping, like that shouldn't make the situation worse. One hopes. I'm going to come to regret saying that, I'm sure. We certainly don't want to deploy anything where we're not confident it doesn't make the situation worse, which is one reason to stick with option 1, where we're like, I think we can be relatively confident it does not make the TLS stack, TLS 1.3 weaker otherwise. Again, one hopes. That's what Nightly is for. So we have a couple of other open issues. This is about how the DNS is deployed. This is deployed in DNS. So David Benjamin pointed out that right now, HTTP service, we allow one HTTP ESNI config per HTTP service record, which obviously means like that whatever like algorithm we have, we're picking like the IP address and the ESNI config is like totally confusing. And if you like pick the IP address and then you're like, oh wait, I don't speak this ESNI config version, maybe you have to fall back. So it's like really goofy. His solution, which I agree with, is to bundle all the ESNI config options into ESNI configs and put that in HTTP service. This like seems totally sensible, and like I think we should do it. If anybody objects like this, speak now. This is PR 200. Okay, PR 201. Oh,
So you can still have multiple ORs for the HTTPS SVC though, right?
yes, but it's probably not a very good idea. Well, it's not a good idea if they have different. No, so, yeah, you can do that. Yes. Sorry, it's a fine idea. Yes.
Okay.
Next slide. Oh, I don't like you doing that. It's like reflex. Okay, so the second thing David Benjamin suggested was to flatten the ESNI config itself. So right now, ESNI config contains like a master list of parameters like the Cypher suites and then multiple key shares. David suggested that we flatten this so you have like one key share per config. And if you want more than one key, then you have more than one config. That's unfortunate. That's an unfortunate typesetting there because when you have multiple ESNI config, you see where I'm going with this. That last S on that last line should not be set in whatever font it is. It should be set in like the main font. Yeah, it's okay. That was you, wasn't it? So the upside of this is nominally implementation simplicity. I'm actually not persuaded that's the case, but David seemed to think it was. Yeah, I know. I have the same thing. The downside, obviously, is duplication, which is that, like, if you have if you have 4 keys, then you end up with 4 copies of the parameters, which look gross. I guess I'm motivated to reject this, but I'm like not gonna lie on the ground over this. I'd like to hear what other people think.
Alessandro Ghedini, Cloudflare. This is how we implemented ESNI already anyway, but from our perspective, it wouldn't change anything. But I also don't really care about I don't see the simplification in the implementation that much, to be honest. I mean, even if we add like multiple keys. So, because like if you have multiple keys, you would have the same negotiation process that you already have for normal key share. So,
but that was why I put that question mark there. I started thinking about this. I seemed like it was harder for me to implement, not easier, because I had to dig into the key shares to find out which one I wanted to pick.
Yeah, Stephen Farrell, I'd be for flattening them. I think getting rid of the complexity in there is a little bit simpler, I think, for me. So.
Ben Kaduk, I mean, I think it depends on how many key shares you actually expect to have. If you're only going to have like 1 or 2, then flattening sounds like a good plan. But if you're actually going to have 4 or 8, then it's another matter.
Tommy Polly, to clarify, does anything stop you from doing 1 key share per ESNI config if you want today?
I don't think so.
Okay, so exactly. So you can get this benefit. It's kind of just an implementation choice. You don't really need to specify it, and it can just be like a best practice to do it that way if people want.
I think the point is that the client negotiation implementation has to iterate over the key shares. So I think the issue is, right, as I understand it, is that I mean, I guess, David, I guess I'm not sure what implementation you have in mind. Like the one I expected, I mean, your implementation is you're going to parse all these and then pick up the one with the key share you want?
So I should probably mention that originally these 2 were 1 PR, and then you pointed out that there was 2 separate things.
Yes.
So I'm actually I don't care too strongly about this one. The motivation was basically looking at Stephen Farrell's draft. The representation for the server configuration is a list of tuples of ESNI config, the public part, and then a list of keys. And so you've got this like double list structure. And so when we were trying to add an API for it, we were like, okay, well, we need to have like add keys, and here's the public thing, and now we need a list of keys over there. And then you call it multiple times. And it just got a little, and it was like, this is kind of annoying. We already have a layer of things. So if you flatten it, then the structure becomes a list of pairs of public thing, private thing, which seemed a little more straightforward. But like I said, I don't care all that strongly.
Right. I mean, so again, I don't care all strongly either. I would have made a stronger case, but from like the way our implementation works is we deserialize the structure and then we negotiate things in sequence, right? And so now what we have to do is like deserialize all the, deserialize the structure, either deserialize all the structures and stuff them in a list, or deserialize the structure long enough to find the key share, then look at which thing and like pass and like stop, like store all the other stuff and then come back. Maybe if we put the key share first, that problem would go away.
Ben Schwartz. So since it's not explicit here, I want to point out that I think that the only significant thing that we're talking about duplicating is the fallback name. The only other thing that I think we duplicate here is the cipher suite identity, which is minimal.
Yeah.
So it's duplicating the fallback name that's of concern here. And the other thing I want to point out is that the ESNI configs or bundle, I like the ESNI bundle name, is still only scoped to a single IP pool, essentially. So if you are in a multi-CDN case, you will still have multiple RRs, and it'll be divided. So that may mean that essentially ESNI bundles are not going to be very large. That is, their scope is still limited.
Okay. I'm not sure. I think that's the chair's going to make progress here. That's the chair tab.
Since nobody's talking on the mic, I'll talk again. Ben Schwartz. I do think that it's a little silly to replicate the fallback name multiple times. So you have an RR from a CDN, and in that RR, you have multiple copies of that CDN telling you its name. Like, this seems weird.
I mean, I feel like maybe we need to have more discussion on the list about this.
Okay.
Than just like, typically like if we have like clear in the room and then we take it, I just don't know that we have that here.
Okay.
For this issue.
Okay. So next steps, I think we're going to publish 06. I think we're going to want to spend some time doing some modeling. Unless somebody disagrees, I'm going to publish 06 with like variant 1 with a nonce. I think the next step ought to be persuade ourselves that like actually this is like safe, at least as far as like not affecting 1.3 before we ship anything. Like I think that would, I'm going to be, despite what I was saying earlier, I'm going to be pretty reluctant to like ship this in a product until I have like some sense, I have some analysis that shows that it doesn't make 1.3 worse. That would be scary. And then simultaneously do modeling on the actual options and see which one we think works, and see like, A, is it possible to avoid modifying the server at all? And B, is transcript secrecy ever a property we don't need under these circumstances? And it sounds like we have a resolution for 200. We'll discuss 201 on the list. Then I think we need to decide on maybe that document is renamed because it's not really ESNI anymore.
That's fine. I mean, I think that it's almost editorial in some respects. So
Okay.
if we decide that we're going to switch to being an encrypted client hello, then we're going to call it something else.
And
Just do that.
I have with it what that should be called Echo, by the way. In case people-
So I guess on 201, the point for the working group is that I still think we should be shooting for starting the working group last call in early 2020. So that to me means like end of January because it's holidays and who knows what. But it would be nice if people could get their eyes on 201 to see if we can, really come to closure sooner. Because
And we certainly can do less call until we have substantially more analysis of this. So I think like that's going to be the gating factor rather than 201. Anything else?
Stephen, what's the question mark after HPK?
Oh, sorry. Thank you. I missed that. So right now we're using this sort of bespoke quasi HPKey thing where we publish a Diffie-Hellman key and then we generate a new fresh Diffie-Hellman key, and it like essentially is HPKey, but it's not actually HPKey. I think I'd suggested, several of us suggested like just hoisting in HPKey. I can't remember. I think someone suggested last time, but I can't remember who it was. Was it Martin? But in any case, I think we probably should do that. But I'm also willing to listen to somebody who says you shouldn't.
So just for what it's worth, I think, I'd be supportive of making the HPK change at the same time now.
Yeah, this is Richard Barnes, one of the HPK co-authors. I think Yeah, I think HPKE is a good operational fit with what you need here, and it should be ready in about the same time frame.
Okay, so one thing that's relevant here is if we do the option 2, we'll need a way to take off an exported key out of the HPKE. Is that something that's being done?
That is something that Chris Wood may have suggested to me and has not been implemented yet, but should be straightforward to add.
Okay, can we get you to start working on that?
PR is welcome.
No, can we get you to start working on that? I know how to make PRs.
I'm sure we can do that, yeah.
Okay, so I'll prepare a PR or one of us will prepare a PR to HPKE to make this HPKE, and we can make sure that like it gets us the list for that. See if anybody objects.
Tommy Polly, Apple. So yeah, thank you for all of this work, and I think the plan sounds good, and all of these options are good things to dig into. Hopefully, we can get this done in that time frame. As a clarification, or also like a bike shed type thing, when we talk about the encrypted client hello, do all of the options require essentially having like the full client hello in there, or is it really just like an encrypted set of extensions rather than a client hello?
Yeah. Good question. I guess my instinct is to, I guess this is a matter of sort of like, shall we say, intuition.
Right.
Like my intuition is get it all in there. Like every time we tried to snake out with less, we've been sorry. So my intuition is get it all in there. I guess really perspective other people have intuitions that are different. I mean, yes, my intuition is to make them as I said earlier, my intuition is to generate like a completely fresh client hello essentially, and have them be different, because I say that the actual space overhead is remarkably low when you except for the keystrokes themselves. So that's like where I am, but like I think other people may be different. I think Richard's like nodding, I told you so, since he like was the person who originally suggested like encrypting basically everything.
Right. Okay. Then that's fine if that's what we have to do. I think some of the concerns that come to my head there are like, now you can have more things that could be not just duplicated but conflicting, and it's less clear how to process them.
Well, it shouldn't be unclear. It shouldn't be unclear to process them. The way you process them is that you parse the client hello. If you see the ESNI, you decrypt it, and then you throw away everything else.
And you just only use
one or the other. Yeah.
Okay.
I mean, modulo this goofy decompression procedure.
Yeah,
yes.
that's fine.
So like that definitely will make clear in the specification. And so like in particular, like like the randoms may be different. So they say this is also a source of tension between greasing and fingerprint avoidance. Because for fingerprint avoidance, it's actually very attractive to have more or less a standardized external client hello, because the only purpose of the external client hello is to allow the server to respond with the fallback keys.
Right.
And so like you don't need like, for instance, post quantum, you don't need like, whatever. But on the other hand, the more you sort of simplify the external client. And so like we can imagine publishing like a standardized one, but the more you do that, the more it stands out that you're like actually doing ESNI.
Yes, unless everyone does that. Yeah. And just one last point. I think part of the reason probably my intuition is the other way is like I come from more like doing Ike, and like there's a lot of precedent there for having your main protocol header, your essentially extensions, and then a block of encrypted extensions. And so there is a fair amount of precedent for that in these type of handshakes.
I don't know. I think it's Nick.
Hello, Nick Sullivan, Cloudflare. Just wanted to clarify one thing specifically about early data. That early data is not in the encrypted hello. It's after the handshake. Just
get quite so. Yeah.
If we do key injection, it becomes much easier to reason about whether you can just do encrypted extensions rather than encrypting a whole client hello.
Why is that?
Because you know exactly what is bound where, whereas this, we're just using TLS as a transport layer, and so modulo decompression.
I ran into follow. Well, I don't follow that, but like I'm not saying it's wrong. I'm just don't follow it. So I think maybe we'll have to pick that up when we start doing the modeling.
Sure.
Well, I'm looking forward to you contributing to it. That's where I'm going with that.
If you want to do an encrypted client hello, and you know exactly and you've bound it to, if you go step back and say we have no interior client hello, and you then just have a key that is used to just encrypt the extensions, you can it's easy to reason about who has that key at what point and whatever, and you can just, if you don't want to work through the, give me 5 minutes.
Sure, yeah, I think that we have time.
We'll buy you a beer.
Now, but like later. Wes?
Wes Hardiker, ISI. So congratulations for actually literally documenting encrypted turtles all the way down.
You're welcome.
And actually right back up again, since you were talking about pointing, back up to the top of the shell. The TLS protocol in general and all protocols in the IETF have had a horrible time when complexity arises that, implementations get stuff wrong. So honestly, as to which I would do, I'd be very tempted to implement both and figure out which one got me more code reuse and less prone to error, because that's a very impressive hack. And I can't believe I followed the whole discussion, to be honest.
Mr. Barnes.
Yeah, this is Richard Barnes again, and feel free to tell me to sit down if this is a dumb idea. But it seems like if we're encrypting the client hello, we could also encrypt the server hello.
Yeah,
in which case it has the benefit of just being encrypted hellos or.
Interesting suggestion. It has the benefit that you can actually, it has the benefit that actually you can distinguish, then you don't have to do decryption. Because you can look at the first byte of the record type, which will be application data as opposed to handshake.
So Deb Cooley, NSA, can I get you to walk through something a little bit? So client hello, inner and outer. You've got the inner one, which you had originally. You're encrypting it and recreating an outer one. Are you gonna force a validation between the inner values and the outer values that are the same?
I'm not just
Are you gonna let them be different?
So, let's take a concrete example.
Yeah.
Yes, the random values can be totally different.
Well, yeah. Okay.
Essentially, unless imagine you're not doing this compression trick. They're totally independent. The compression trick is, they're obviously the ones that are deduplicated, can't be different. But the ones that are not deduplicated, yeah, they're totally independent. Is the idea.
Yeah, Ben Kadek. So you can imagine a world where you are doing the fingerprinting avoidance where the outer client hello is literally fixed except for the encrypted bit.
Yeah.
And so then, they're always going to be different inner and outer.
Oh, I see. So you're not going to encapsulate anything on the inside that you're also carrying on the outside?
Only for convenience.
Yeah, the outside is just for the case you have to fall back and do the finish the handshake, but sort of fail the operation by returning the new ESNI keys.
So I guess when you started talking about this, it sort of threw me back in time to a protocol called SP3, which is an early IP protocol where you did encapsulate. You had an inner header and an outer header, basically, and you had to be careful to you passed it or you translated it, or you had to be careful about how you did it because you had things in both places. And you talk about IKE and IPsec, it's sort of the same idea there too. If you had values in both places, you need to make sure that this one's the same as that one.
Yeah, I think that we're taking the opposite posture, which is
you're just not having it,
which is you ignore you don't check them, you just ignore one or the other.
Yeah, in Vane of Wes's point, because some implementations.
No, or you don't have it. You can't have it both places.
Well, in this case, in the most trivial case, right? You would have you would have a key share in the outer client hello, and you'd have one in the inner client hello, and they'd just be unrelated, or at least not.
Well, they're for different purposes, right?
No.
No.
Let's say ALPN. No, they're not. They're for different purposes. In the case of the outer key share is for the server to use for fallback, and the inner key share is for the server to use for completing the handshake normally.
Yeah. So I'm thinking, so here's an analogy, and it might be a bad analogy, but it's an analogy, right? So you're writing a check. Maybe some of you have never written checks before, but I'm old.
I have written a check.
So you write a check. When you write a check, you put the numbers of the value of the check, and then you write out in words the value
Yes.
as well. Those things are supposed to match.
Right.
And
So-
if they don't, you have problems.
Right. So in this case, they're supposed to be independent.
So they're different, right? Yeah.
Or
all right.
not, but they don't, you don't care if they're different or the same.
So you don't care if they're the same as in the check. If you have different values, you have a problem.
Yes, this thing is different from the check.
Yeah. Okay. All right. This is interesting. It's been a little while since I've looked at this.
Please do, because obviously this is extraordinarily complicated.
Is there going to be a way to not do this?
Yeah, you won't have to. You can just not do it at all.
Okay.
I
Awesome.
mean, in fact, there'll be a lot of clients. I imagine that many people will not do it. I wish more would.
More would not do it, or more?
I
would
wish
do it?
more will do it, but I imagine many will not.
Well, we'll let you know.
What'd you say?
We'll let you know.
I said we'll let you know.
Oh, that's good. Yeah. I try to make products people like.
Ben Schwartz. So, 2 free ideas. 1, like CTLS, you could treat these inside to outside references as reconstructed. That would put them into your transcript. Put the imported values into the transcript.
That's what's supposed to happen. I'm sorry if I wasn't clear.
Oh, okay. Thank you. And the second is your ES&I bundle could actually provide instructions for fingerprinting resistance, for example.
That's a quite interesting suggestion.
Daniel Kahn-Gilmore. One thought in response to Richard Barnes' suggestion of just having encrypted server hellos in response once things are encrypted, is that gives a signal to the observer on the outside whether or not the encrypted client hello is accepted. I'm not sure that we want that signal to be visible.
Yeah, we went back. There's a comment in the PR about that, I think, because I was going back and forth for the same reason. That does seem like an obvious drawback. I think that the thing that made me less worried about that drawback than I otherwise was is that the only real reason why the server would accept or versus reject is if the ES&I config corresponds to a key which it recognizes versus not recognizing, and you can probe for that directly. Anyway, you can generate your own perfectly good ES&I client hello using that same key and see if it's accepted versus rejected. So obviously passive and active are not the same thing, but that's a reason why we might care less than we otherwise would.
Right.
Again, I'm going back and forth on this too, so I understand that. Sorry.
Okay. I just wanted to observe also, since we were talking about weird analogies that may or may not be appropriate, that the work that's going on in LAMPS right now about protected email headers has a remarkably similar smell to this.
Yeah, and a smell is in fact the right word.
So we got 3 minutes left in this session, so please keep it brief.
Tony Pauly, Apple. Just to the point of if we have stuff to duplicate and checking, I'm concerned that if we say, oh, we're going to ignore them, but they're probably going to be the same, that's not going to be the case. Like at some point, once everyone's doing ES&I, people will use the fact that there are different values to give different signaling. And so I think if we have duplicated values and some outside and some inside, people will start using that joint for things. And we need to think about the consequences of that.
Yeah, I mean, one thing is we could simply require that anything that wasn't duplicated be independently generated. People may not follow that. But,
yeah. I came up with a really great way of solving this problem and then suddenly realized that it depends upon an IP, a web PKI certificate with an IP address in it, which of course we have banned.
That's not true. You can get a PKI certificate with an IP in it. We have one for 1111. So Nick Sullivan, Cloudflare. I'd like to point. So if we go back to the 2 options, I'd like to point out that these are not necessarily different. I think option 2 can be complementary to option 1, and I recommend that we go forward with option 1 and implement and spin a draft, as you said, do the analysis, and this will protect against passive observation, right? And option 2 is something that can be implemented as a separate extension inside the encrypted client hello. And I think these are both complementary, and doing option 1 without option 2 gets you some of the way, and together gets you, I think, all the way. So
Thank you.
I think this is a good direction.
Thank you. You have 19 seconds.
Okay, hopefully this will be clear this time. With the injected key, you know that the backend server knows the injected key. With the tunneling, you don't know that the backend server knows the key, and in split mode it doesn't.
Agreed.
So the reasoning is simpler because you know that the other side knows the key.
Thank you.
So the one thing we didn't get to is charter discussion. Thank you. Thank you for this lively discussion. It was good. We bumped the charter discussion because this is way more important. We are basically going to take the charter discussion to the list. If we start adopting all the drafts that we sent out working group adoption calls for today, we have to recharter. So let's consider that. It'll be a prerequisite. So look forward to having that lively discussion on the list. That the chairs have taken a shot at the charter, and we look forward to your edits. Thank you. All right, we're even like marginally on time. Good job, guys. Don't forget your plugs. You know, I'll send you a draft stuff because I just want to. Like, we should just push this. Yeah, well, we'll see. You have a question?